Welcome to Sleepy Scientist Stories. I'm truly glad you've arrived. Maybe you're listening in the quiet, nestled beneath blankets, or simply resting in the hush of evening, letting the strain of the day fade. Maybe your thoughts have been swirling too fast, or maybe they've gone still, hoping for just a little softness. However you feel, this space belongs to you. A quiet corner of the universe where science drifts gently and no question demands a quick answer. You're allowed to breathe here. You're allowed to pause. This isn't a classroom, it's not a lesson. It's something slower and warmer, like sitting beside someone as they wonder aloud, not to explain but just to notice. The world spins quickly enough without us keeping pace. You don't need to rush. Not here. Tonight's story begins not with something loud or complicated, but with something so familiar, it's nearly invisible. Time. Not the kind we check on a screen, not the digits on a microwave, or the voice from a speaker telling you it's 9:42 p.m., but the quiet thing underneath, the presence we call time. We live inside it, we plan around it, we feel ruled by it, but we rarely stop to ask what it actually is, or where it comes from, or whether it behaves the same for everyone everywhere. That's the question we'll follow tonight. Slowly, curiously, without needing a final answer. Does the universe know what time it is? At first it sounds like something a child might whisper, half asleep, staring into the dark. But the more you linger with it, the more strange and serious it becomes. Because we don't just use time, we live it. Each breath we take unfolds inside it. Our memories stretch behind us in it. Our hopes lean forward into it. But does the universe recognize any of that? Does it keep track of now? Or is time something we've created, a way to keep our minds from drifting? What time is it for you? Not by a clock, but by feeling. Does it feel late where you are, or early? Are you in the middle of something, or slowly letting it go? Time stretches. Time slips. 1 minute can drag endlessly. A whole afternoon can vanish like mist. We treat time as solid and steady, but our experience tells a different story. And physics agrees. Time doesn't flow in a single rhythm. It bends, it twists, it moves differently based on motion and gravity. That means your time right now may not match someone else's, even if they're sitting right beside you. So what does that mean for the universe? For the way it holds together? For whether it needs time at all? That's the path we'll follow. Gently, patiently. We'll look into relativity, clocks, and the curious truth that time might not be what we think it is. We'll see what happens near black holes, what time looked like when the universe was young, and why your past and future may be more connected than they appear. But we'll move slowly, just one thought at a time. If this kind of science, the quiet, thoughtful kind, helps you breathe a little deeper or drift more easily into sleep, a like or a gentle subscribe helps others find it too. Now, take a moment, let your shoulders drop, let the day step back. There's nothing here to catch up with, just sound, just questions, just rest. You don't need to look far to realize time doesn't always behave the way we expect. Some days slip away before you even notice. Some nights stretch on, endless, even though the clock barely budged. That contrast between the time we track and the time we feel is easy to miss. But once you start noticing it, you begin to wonder, is time as fixed as we believe? Or have we just grown used to pretending that it is? That's where the real question begins to deepen. Not just what is time, but is time the same for everyone? And even more curiously, does time exist the same way for the whole universe? We won't answer that all at once. We'll sit beside it for a while, noticing the way it hums beneath our thoughts. Let's begin somewhere familiar. A clock. It could be the one on your phone, your wrist, or your oven. They all do the same thing. They break time into pieces. Seconds, minutes, hours. But what are they really measuring? Old clocks use movement, gears spinning, pendulums swinging. Digital ones rely on vibrations or electric pulses. Atomic clocks, the most precise tools we have, count the oscillations of atoms, billions of times per second. But even they aren't measuring time itself. They're measuring change. change that repeats. And in physics, that's what time becomes. Not an object, but a relationship. One state turning into another, a signal shifting, a system evolving. Time, then, isn't something you can hold. It isn't made of anything. It's a rhythm we define between moments. But once you frame time this way, as something measured only by change, a new puzzle emerges. What happens when nothing is changing? If you were floating, still and alone, far from stars or planets, far from sound or movement, how would you know a second had passed? A minute? An hour? Without change or memory, what would time even mean? This isn't just a philosophical game. In physics, this is a real question. Some would argue time still exists in that emptiness. Others say it doesn't make sense to talk about time unless something's happening to mark it. In such silence, time becomes something theoretical, useful in equations, but invisible in reality. And this is where our normal feeling of time begins to slip, because as soon as you examine it carefully, the ground beneath time starts to move. Take two identical clocks. One stays with you on Earth, the other you send up into space or place on a fast-moving jet. When you reunite them, they'll disagree. One will have ticked slower than the other. Not because it broke, not because of an error, but because time flowed differently for each. This is not an idea, it's a fact. Measured, verified. One of Einstein's most famous predictions, and one of the most repeatedly confirmed in modern science. According to relativity, time isn't universal. It isn't a single rhythm playing through the universe. It's elastic, shaped by motion, warped by gravity. And this isn't a minor technicality. It's crucial to your everyday life. GPS satellites orbit above us, and because of their speed and position, they experience time slightly differently than we do on Earth. Their clocks must constantly be adjusted, or your phone's location would drift by kilometers every day. Even your head and feet experience time differently, ever so slightly, because gravity at your feet is stronger than at your head. The difference is tiny, but it's real. And once you see that, the idea of a single time for everyone begins to fall apart. That's where space-time enters the picture. Einstein realized space and time aren't separate. They are part of a single fabric, one that curves, stretches, and bends in response to mass and energy. And those curves shape the motion of everything: planets, light, and clocks. When you feel gravity pulling you down, what you're really sensing is the shape of space-time beneath your feet. You're resting in a curve, and that curve affects how time moves for you. Not metaphorically, literally. The more massive something is, the more it warps the space-time around it, and that warping changes how time passes. It slows near mass, it quickens away from it. So the question, does the universe know what time it is, becomes more complicated. Which time? Where? Measured how? And what does it even mean for the universe to know something? To approach that, we have to look inward. How do we feel time at all? We don't sense space-time directly. We don't feel time bending beneath us. We feel only the steady beat of moments. A rhythm, one thing after the next. But physics shows us this rhythm isn't absolute. It's one thread in a tangled weave. Different observers, moving in different ways, in different places, might disagree on the order of events. One person's now might be another's past. Simultaneity dissolves. There is no universal present. That's hard to accept. We crave a shared timeline, a single now. But the universe doesn't provide one. It allows different frames, different perspectives, different clocks. And so time becomes local. It's not erased. It's individualized. It becomes part of your motion, your place in the cosmos, your path through space-time. But what about the empty places, the distant regions between galaxies, the voids where little moves? Does time still tick there? One answer is yes. Time exists wherever space-time exists. The geometry continues, even without things inside it. But if there's no change, no process, no way to mark it, then time becomes a ghost, present but inaccessible. Some scientists go further. They suggest time might not be fundamental at all. It might arise from deeper structures, quantum fluctuations, entropy, entanglement. In this view, time isn't something the universe has. It's something that emerges when conditions are right. That would mean the universe doesn't know what time it is, because time wouldn't exist for it to know. It's unsettling. We're so used to time being simple, ticking forward, carrying us with it. But even that flow, from past to future, isn't something guaranteed. The equations of physics work just as well in reverse. The universe doesn't prefer forward or backward, and yet we experience a direction, an arrow, a memory of what was, and a pull toward what could be. Why is that? That's something we'll explore soon, but for now, just let the question linger. What is time, really? And if we can't define it completely or measure it universally, if we can't agree on when now is, what does that make time? Not unreal, but not what we assumed. And maybe that's enough for now. You're lying still, in your own moment, in your own corner of space-time, with your own gravity, your own movement, your own pace. Someone else, somewhere else is doing the same, but their time flows slightly differently, not because anything is broken, but because that's how time behaves. Flexible, responsive, local, that's part of the beauty. So, if we ask again, does the universe know what time it is? Maybe the most honest answer is, it doesn't need to. Because no one answer exists, and we're only just beginning. Gravity curves the fabric of space, and with it, bends the rhythm of time. Right now, on the surface of Earth, you live inside a gentle gravitational field. Not a pull, exactly, not like a hand tugging, but a quiet bend that shapes the way time flows for you. If you were to move higher, say aboard the International Space Station, drifting above the blue curve of the Earth, your time would stretch slightly faster than it does here on the ground. The difference is incredibly small, but it isn't imaginary. It's real. Our satellite systems depend on it. Your GPS would lose its place without it. If we ignored how motion and gravity affect time, your phone could send you kilometers away from your true location. So, time, as we live it, isn't a single thread, it's many, each one shaped by its surroundings, each one flowing just a little differently. And as those surroundings grow more extreme, the differences become impossible to ignore. So let's drift outward, beyond Earth, beyond the calm orbit of satellites, into the darker folds of deep space. Picture an astronaut circling near a black hole, not falling in, but hovering just beyond the edge, just outside the event horizon, that invisible boundary where nothing escapes. From inside their suit, time seems steady. Their breath moves, their heart keeps pace, their thoughts unfold in ordinary rhythm. But, from far away, from where you are, their time appears to slow, their motions become syrupy, their signals stretch. You'd watch their clock and see it pause between ticks, while yours moves swiftly forward. Their time has dilated, stretched, slowed, and if they drifted just a little closer, slipped past the edge, that difference would become absolute. From their view, they'd keep falling, keep thinking, keep moving. But from your vantage, they'd stop. Their image would freeze just above the event horizon. You'd never see them cross. Their final moment would hang there forever, locked outside time, not lost, but unreachable. And this isn't science fiction. It's a real effect, one of the strangest truths in physics. Time is not absolute. There is no master clock ticking across the stars. There is no shared now. Your now and someone else's now might not align. Even light, that most constant of things, cannot unify our clocks. It moves faithfully through the vacuum. But it takes time, so when you look up at the stars, you don't see them as they are. You see them as they were. Some lights reaching you tonight began their journey millions of years ago. Some stars may no longer exist, yet their glow still travels on. While that light moved toward you, your own time continued. You aged, you learned, you slept and woke. But somewhere far away, time flowed differently. Their clocks moved at another pace. Their now no longer lines up with yours. And the farther apart things become, the harder it gets to say what's happening at the same time. That's why physics introduces a different idea. Proper time. Not global time, not shared time, but the time that belongs to a particular path, a particular observer, moving through the world in their own way. Your watch tells your story. Mine tells mine. Both are truthful, even if they don't match. Imagine a great city spread wide with neighborhoods where the clocks all run slightly differently. You cross a street and suddenly you're 2 seconds ahead of your neighbor. Not because you rushed, not because time broke, but because the fabric of the world shifted beneath your feet. In daily life, these differences are tiny, smaller than we can feel, but in more extreme places, near neutron stars, in particle accelerators, at the edge of black holes, the differences become dramatic, measurable, inevitable. And this forces us to release an old idea, the idea of one single timeline, one shared history, because our universe doesn't run on a single schedule. It flows on countless overlapping rhythms, and when we ask, what time is it? We're really asking, what time is it right here, for me, in this small pocket of existence? Even the cosmos shows us this truth. Some regions have aged more than others, not by date, but by experience. Some places have lived through more time, others less, depending on how the curvature of space-time has shaped them. Some parts of the universe have simply had longer to unfold, and we can measure this. We've watched fast-moving particles decay more slowly. We've tracked the way light bends and slows near massive objects. We've listened to the shift in distant frequencies, all of it pointing to the same quiet fact. Time does not pass the same way for all. So what time is it? That depends. Whose time are we measuring? If every clock tells a slightly different tale, then the universe doesn't carry a single story. It holds many, layered, drifting, intertwined, woven not by a master schedule, but by the relationships between things, cause and effect, mass and motion, signal and distance. And that's a kind of beauty. Time is not rigid, it's responsive. It adapts to where you are and how you move. It bends with gravity, it stretches with speed, and there is no cosmic referee keeping things in sync. The universe doesn't care about schedules, it only cares about connections, how one thing affects another, how paths intertwine, how moments ripple outward. There's no ticking metronome behind the stars. There is only the web and the flow inside it. And inside that web, you live. Your heartbeat, your thoughts, your memories, all unfolding in your own stream of time. Your time, no one else's matches it exactly. And that might feel strange, but it's also gentle, because it means your experience is valid, even if no one else shares it. Your time is real, shaped by your place, your speed, your gravity. And that means your path is not fixed. Your future is not locked. Time can bend for you too. It can stretch and curve. It can slow down in the right conditions. There's a moment, a very human moment, when you find yourself staring into something unknown. You pause. You haven't moved, but your thoughts stretch forward, searching for understanding. In that pause, time feels thick, almost slowed. That sensation, that gentle delay, isn't far from what happens near something massive, because gravity doesn't just pull on you, it pulls on time itself. Let's stand beside something heavy, not just a mountain, something truly dense, a place where matter is packed so tightly it alters the flow of time around it. You wouldn't need to see anything strange to know it was there. The equations would tell you, the clocks would prove it. Take two identical atomic clocks, place one here on Earth, send the other just a few hundred kilometers up, let them run. When you bring them back together, they will disagree. The one that floated above will have ticked slightly faster, not because it malfunctioned, but because time ran faster for it. This is gravitational time dilation, and it's not just a theory, it's something we correct for every day. GPS satellites operate in weaker gravity than we do. Their onboard clocks tick slightly faster. Engineers adjust for this constantly. Without those corrections, our systems would drift within hours. Planes would miss their routes. Your phone wouldn't know where you are. The world assumes time is steady, but its machines are built to handle the truth. That time varies. Now imagine a black hole. Not a monster pulling everything in, but a place where matter has collapsed so deeply that space and time themselves curve into a tight spiral. You don't fall toward it because it sucks you. You fall because the geometry around it changes. If you hover near it, just above the event horizon, you can remain if your engines are strong enough. From your point of view, nothing is unusual. You think, you breathe, your watch ticks forward, but far away someone watching sees your motions slow, your signals stretch, your clock falls behind. To them, it looks like you're suspended, frozen just outside the black hole. They never see you fall in, not because you vanish, but because time itself bends so far that your final moment becomes unreachable. You'd feel none of this, but their perspective tells a different story. Time hasn't broken, it has warped, and we can predict this. Einstein's equations say this must happen, and the universe agrees. This leads to strange but beautiful possibilities. If you spent an hour near a black hole, you could return to find centuries have passed elsewhere. Entire histories might have unfolded while you lingered in a stretched moment, and both your experience and theirs would be real. You didn't move quickly. Time itself flowed differently for you. That's what time dilation means. Not just illusion, but physical difference. Your timeline and theirs diverge. Two truths coexisting, each carved by the shape of the space-time around them. So if time can stretch, if it can warp this way, what is it stretching into? What allows that motion, and how far can it be pushed? In relativity, time is not separate from space. It's one dimension in the fabric of space-time, just like left and right, up and down, and massive things bend that fabric. When you stand near something dense, you're not just feeling gravity, you're standing in a curved piece of space-time, and as you approach something like a black hole, it's not just that you're pulled in. Time itself begins to tilt inward. Standing still becomes harder, moving forward becomes natural, and all the while, time slows around you. We first imagined these ideas in fiction, stories of travelers returning home after years had passed, worlds where time is stretched by massive suns, but the physics is real. In 1976, Gravity Probe A flew a hydrogen master clock 10,000 kilometers above Earth. Scientists compared its time with an identical one on the ground. The space clock ticked faster, just as theory predicted. The difference was tiny, but it was real. And we've seen it again and again. We've watched the orbits of stars near the center of the Milky Way, spinning close to a massive black hole. Their paths curve, their light shifts, and the time they live through is not the same as ours. This teaches us something profound. Time is not a stage on which the universe plays. It is a part of the play. It's shaped by mass, molded by energy, altered by motion. It is dynamic, alive, local, and it's not something we move through passively. It's something that changes with us. We see this in gravitational lensing. When light bends around a distant cluster, it's not just taking a curved path. It's experiencing a stretch in time. It arrives not when it began, but when the universe allows. Time isn't lost, but transformed. And so we begin to understand. A moment is not universal. It's personal. If you sit quietly, your now is yours alone. Someone in orbit, someone far above or far below. Their now is a little different. Their seconds unfold at a slightly altered pace. And when you both look back, your histories won't align exactly. They will be close, but not the same. That's the cost of living in a curved universe. And it's also the gift, because it means the cosmos is not rigid. It flexes, it adapts, it remembers, and each clock, each path, each observer carries their own melody, their own timing, their own rhythm. Even the early universe lived by different rules. In those first moments after the Big Bang, space expanded quickly. Time, as we understand it, flowed faster, or slower, or something else entirely. Because when everything is curved and compressed and changing, time itself loses its usual shape. And even now, far away, in places we cannot reach, time may still be unfolding differently. The universe may contain regions we'll never see, not because they don't exist, but because the light from them will never arrive. And in those unreachable corners, time may be moving at a different pace. Not wrong, just different. So what time is it? Here. Now for you? That's the only answer the universe gives. because there is no single now, only many, woven across the cosmos, flowing like rivers beside each other, shaped by gravity, stretched by distance, bent by speed. And in each one, someone lives, someone breathes, someone wonders. Time isn't a single drumbeat, it's a symphony of rhythms. And tonight, you're listening to your own. And out there, in the quiet corners between stars, another clock is ticking. Not fast, not broken, just different. Because that's what time does. It stretches, it shifts. Most of the universe is made not of stars or planets, but of emptiness. Not empty like a quiet room, but truly, physically empty. Vast reaches between galaxies, where no warmth drifts, no sound echoes, no light flickers. These are not just dark places, they are nearly untouched by matter. No voices, no echoes, no steps. And yet, even there, time is not lost. Or at least, that's what we believe. Even in the absence of clocks and motion and measurement, time still moves, slowly, softly, invisibly. Imagine you drift beyond the pull of our sun, far, past the last breath of its light, where gravity's grip weakens and silence reigns. There's no bell tolling the hours, no rhythm to speak of, and yet something still changes. Particles still wander, radiation still flows, gravity still whispers. A dust grain without destination still responds to invisible pulls. In this kind of silence, time becomes hard to feel. There's no heartbeat to measure against, no rise or fall of brightness, no sound to count. But the geometry of space-time, the structure itself, still exists, and that structure carries time within it. It doesn't vanish when things fall still. It remains, a scaffold for possibility, a quiet canvas for change. If we launched a spacecraft into that darkness, its clock would keep ticking. Its systems would log each second faithfully. But those seconds wouldn't match ours here on Earth. The ship, drifting far from gravity, would feel time slightly faster. That's what gravity does. It slows time. And in the vast spaces between stars, gravity is softer than almost anywhere else. So time flows more freely, though so gently it barely stirs. Those empty stretches aren't outside of time, they're just quiet. Quiet enough to feel timeless, but not truly so, because even when stillness rules, time remains. Not loudly, but always. And that matters, because it teaches us that time doesn't rely on action. It doesn't need a pendulum, or a ticking hand, or a glowing screen. It doesn't demand movement or sequence. It's part of the stage itself, built into the scaffolding of the cosmos. If space is present, time is too, even if no one is there to notice it. That truth becomes sharper when you think about light. A star sends out photons, tiny packets of light, and they travel, never stopping unless something interrupts them. Through gas, through planets, through the deepest emptiness, they carry with them a record of time. Light doesn't need air to move. It doesn't need help. It moves steadily. From the sun to Earth, 8 minutes. From the nearest star, more than 4 years. From the edge of what we can see, over 13 billion years. The light still arrives. The path still exists. And with it, so does time. None of those distant places are synchronized with us. They aren't moving through time as we are. But the light that reaches us took time to get here. Measured, meaningful time. And that tells us something powerful. Time isn't layered on top of space. It's embedded in it. It is part of the distance, part of the path, part of what makes motion meaningful. So if you were floating out there, between galaxies with no star in sight, time would still flow for you, even if you felt nothing, even if the silence was total. You would still have a place in space-time, and that place carries its own rhythm. But that opens a deeper question. What do we really mean when we say time flows? It's easy to imagine time as something that moves, a stream, a wind, a river. But in physics, time doesn't flow. We move through it. Events unfold within it. But time itself is a dimension, like length or height. It doesn't sweep across the universe like a breeze. It doesn't pull us like gravity. It doesn't run like a current. it exists. It has direction, but not motion. So when we look at the silence between stars and feel like nothing is happening, physics reminds us, something is happening. Not loudly, but enough. Because even there, in the quietest stretches, tiny things still stir. A hydrogen atom, the simplest kind of matter, may drift for eons without encountering anything else, but it still exists. And that existence includes time. Occasionally, something more energetic passes through. A cosmic ray from a distant supernova, zipping across space at near the speed of light. Those particles obey time. They decay. They scatter. Their movement is real, even in the emptiness. They age. They follow laws. And even the most ancient thing, the cosmic background radiation, carries a time stamp. It's the whisper left behind by the Big Bang. It has cooled and thinned and stretched, and we can still hear it. We can still measure how far it's come. Time is woven into its very texture. So the void between stars, the silence we imagine as frozen, is full of time. Not in the way we're used to, not with ticks or beeps or schedules, but rich, steady, enduring time. Time you can't feel. But that still holds meaning. Think about sleep, when you lie still in the dark, eyes closed, body quiet. Time doesn't stop. It just becomes harder to follow. Your cells still divide, your muscles still repair. You still age, you still breathe. Time doesn't care whether you notice. It continues. Interstellar space is like that. Not lifeless, just hushed. Not paused, just still. And even in the deepest emptiness, where not even a single atom drifts, space-time still exists. The geometry remains. It isn't erased by silence. And where there's geometry, there's time, because even space without substance has shape. That shape may be faint, but it's real. The laws of physics still apply. The equations still hold. And if space holds shape, then that shape includes direction. And if there's direction, there is time. You can imagine it like this. The universe is a vast stage. We tend to look where the lights shine, where stars burn, where galaxies swirl, where life exists. But the stage doesn't end in darkness. Beyond the lights, in the wings, the floor continues. The walls are still there. The structure is intact, waiting, not watching, not thinking, just continuing. Space doesn't anticipate. Time doesn't hope. They simply are, and their being shapes everything else. If you sent a spacecraft into that silence and left it untouched for 1,000 years, it would not be preserved. It would change. Its circuits would degrade. Its fuel would break down. Its systems would weaken. Not instantly, but slowly. And when you returned, it would be older. That aging is not a metaphor. It's time made visible. So yes, time exists even in the breath between stars, not as noise, but as framework. And even if no one's watching, it's still there. But here's the subtle truth. Time is only visible when something interacts with it. It's always present, like space, but unless something stirs, it's difficult to notice. That doesn't make it any less real. It just makes it easy to forget. But we don't forget. We are built to feel time. We don't always measure it precisely, but we notice its presence in hunger, in memory, in fatigue, in cause and consequence. And so, even in stillness, we sense time. That's why the silence of the cosmos feels so strange. It lacks the feedback we crave. No movement, no rhythm. But still, time unfolds. One day, a comet may swing through that space. It may wander for millennia before being drawn toward a star. And when it does, it obeys gravity. And gravity obeys space-time. And space-time includes time. It always does. That's the link. Even in silence, time persists. The breath between stars isn't a gap. It's part of the music. A softer measure, but still part of the melody. If you could sit there, weightless and alone, your heart would still beat. Your thoughts would still drift. Your seconds would still come. Maybe slower, maybe deeper, but they would still arrive. Because that's what time does. And that's why the question, does the universe know what time it is, remains hard to answer. Because in one sense, yes, it knows time, but only in pieces, not in one voice. Each place carries its own time, and in the places where nothing speaks, time still listens. We'll come back to these stretches again. But now, let's take the question further. If time exists even in stillness, what gives it direction? Why does it feel like it moves forward? Time is often described as a river, flowing forward, carrying us with it. But rivers have rules. They follow gravity. They carve paths. They split and rejoin. Time doesn't seem to do that. It doesn't loop back. It doesn't branch or hesitate. And it doesn't flow through a landscape. Or does it? We talk about the past as behind us, the future as ahead. But in physics, time doesn't require that orientation. Most of the fundamental laws, the ones that govern particles and forces, are time symmetric. That means they work the same in both directions. If you played them backward, the equations wouldn't care. Think of two billiard balls colliding. Played in reverse, it still makes sense. The math still works. The forces still balance. There's nothing in Newton's laws that insists on forward time. It's just our perspective. So why do we experience it in one direction? Why don't we remember the future? Why do we grow older, not younger? The answer lies in something called entropy. Entropy measures disorder, or more precisely, the number of ways a system can be arranged while looking roughly the same. High entropy means more disorder, more randomness. A neat deck of cards has low entropy, a shuffled one has high entropy, and in every closed system, entropy tends to increase. That's the second law of thermodynamics. Order decays. Systems spread out, energy disperses. Not because disorder is better, but because there are more ways to be disordered. That tilt, that statistical imbalance, is the only true arrow of time. Entropy rises, and that gives us before and after. That's why an egg breaks, but never unbreaks. Why smoke rises, but never falls back into a match. The equations would allow the reverse, but the odds make it near impossible. So even though time itself doesn't care which direction it moves, the universe's starting conditions do. The early universe was low in entropy, and ever since, it's been climbing. That climb defines the arrow, not a push, just a tendency. And that direction, that one-way rhythm, is what we feel as time moving forward, not because clocks require it, but because experience does, because the world changes in one preferred direction, from cold to warm, from dense to diffuse, from pattern to blur. Even so, this direction isn't fixed by the laws of physics. It's a product of conditions, a perspective, a shared drift, not a rule. And on the largest scale, the universe is not a river. It is a web, made of paths, of connections, of local flows, each system with its own tempo, its own sequence, its own rise in entropy. The arrow of time emerges not from one clock, but from many aligned ones. Most systems move the same way, but some don't. Quantum systems, for example, can behave in ways that seem outside this flow. Particles can become entangled, linked, so that one reflects the other, no matter the distance. In those moments, time seems less like a line and more like a map, a structure, a set of connections, not steps. Even on larger scales, time doesn't flow equally. Some galaxies move differently. Some regions age faster. Gravity bends not just space, but time. So the arrow is not universal, it is local. And yet, here we are, moving forward together, caught in the same soft current. So if time flows in silence, and if its direction is born from disorder, and if each path holds its own rhythm, then perhaps the universe does know what time it is, not in a single beat, but in many. Some places move slower, some clocks beat faster. Time, it turns out, isn't a steady stream. It's a fabric with folds and eddies, a landscape with swells and valleys. In some places, the current moves gently. In others, it twists, it slows, it loops in strange geometries depending on local conditions. That's why physicists today think of time not as a flowing substance, but as a shape, a property of space itself. Not a river, but a structure. Something that stretches between events. Something you move through, not on top of. And how you move depends entirely on where you are and how fast you're going. In this view, time isn't separate from space. It's a dimension, the fourth one. 3 describe your location. The fourth says when you are. Not just your place, but your moment. Time becomes less of a path and more of a field, a woven web of possible routes, each shaped by motion, each marked by gravity. You move through that web differently depending on what you feel and how you travel. Accelerate, and your time slows down. Drift deeper into a gravitational well, and your time slows again. Take a different trajectory through space, and you might arrive at the same destination but with fewer ticks on your clock. This isn't imagination. This is measurable. The metaphor of a river tries to simplify all of that into one direction, one current, but nature doesn't always move in straight lines. The universe isn't a river. It's a terrain, a flexible sheet, a living surface that changes depending on who's looking and where they are. That doesn't make time unreal. It just makes our experience of time deeply dependent on our surroundings. Biology, gravity, memory, heat, they shape what we feel. But the deeper structure beneath those feelings, that's geometry, and that geometry opens up strange possibilities. If time is a dimension as real as length as height, then perhaps past and future are places. Just like other points in space exist, whether you're standing there or not, the moment of your birth, the moment of your last breath, both could exist in the structure of space-time, fixed, mapped, waiting, but you can only travel one way. That's the strange part. Physics permits the map, but your body, your brain, your experience, they only walk the path in one direction. One breath, then the next. One heartbeat after another. You don't get to jump ahead. You don't get to rewind. You move forward, even if the landscape doesn't demand it. So if all events exist in space-time, the past, the future, the now, then what makes the present different? What sets it apart? That's not a question we've answered. Some physicists say the present is the only thing that exists, that the past has vanished and the future hasn't formed. Others say every moment is real, equally solid, equally eternal. That flow, the feeling of time moving, might not be a property of the universe at all. It might be perception. It might be memory. It might be what happens when entropy gives us a one-way track. And that's the challenge. You can't step outside time to look at it. You're inside it, describing it from within, always too close to see its shape completely. But what we can say is that time doesn't behave like a current. It doesn't have to move in one direction. It can bend, it can stretch, it can slow down and speed up and curl into strange patterns. In a network, what matters isn't direction, it's connection. Where you are, what's nearby, which routes you can take. You feel time moving forward because your memories arrange themselves that way. Because causes come before effects. Because heat flows from hot to cold. Because entropy increases. But under that flow is something more flexible. Something that allows loops and layers and regions where things unfold differently. You are not drifting along one stream. You're moving along a thread in a web. And every thread is shaped by the gravity near it, the motion through it, the curvature beneath it. So when you wonder why time moves forward, what you're really asking is, why does the local shape of space-time push you that way? And the best answer we have is this: it started that way. The early universe was simple, ordered, low in entropy. That gave direction, that gave memory, that gave time its arrow. But there's no law that says every corner of the universe must follow. Maybe, far from here, entropy falls instead of rising. Maybe the arrow points the other way, not in contradiction to physics, but in harmony with it, just taking a different route through the same web. It's a difficult thought, but not an impossible one. The math allows it. The structure makes room. We hold on to it not as an answer, but as a possibility, because if time were simple, we wouldn't need curves to describe it. We'd call it a line. We'd measure it like distance, straightforward and even. But we don't, because time, when observed carefully, resists that shape. This is where relativity begins to speak. You don't need to understand all the equations to grasp the heart of the idea. Start with something intuitive. Not everyone agrees on when things happen. Two people watching the same event from different positions or moving in different ways may not describe it the same way. One might say it happened before something else, the other might say it came after, and both could be right. That isn't confusion, that's reality. In the early 1900s, Einstein took what people thought were separate, space and time, and wove them into one structure, space-time. That sounds abstract, but its effects are real, because when space and time are connected, bending one bends the other. They stretch together, they move together, they don't operate alone. This shift made time no longer a background. It became part of the scene, dynamic, curved, reactive. Special relativity is the first layer. It shows that motion affects time. When you move fast, especially near the speed of light, time slows down for you, not just in theory. Physically, your body processes stretch, your seconds lengthen. You age more slowly compared to someone who stays still. This isn't fantasy. We've tested it. We've watched unstable particles live longer when moving quickly. Their clocks tick more slowly. Even astronauts in orbit come back ever so slightly younger than their counterparts on Earth. The difference is tiny, but real. That's special relativity. Motion changes time. General relativity adds something more. It says gravity curves time too. Imagine a stretched surface, smooth and flat. Then place something heavy in the middle. The surface sags. That's what mass does to space-time. It curves it, and things that move nearby follow those curves. That's gravity, not a pull, but a path. Planets orbit stars not because they're pulled, but because they're falling through curved space-time. And those curves don't just affect motion, they affect time. The deeper the well, the stronger the gravity, the slower the time. Stand on a mountain, and your clock ticks a little faster than it would at sea level. Send a signal down into a deep mine, and it loses time on the way. These are not illusions. These are measurements. Atomic clocks confirm it again and again, and near a black hole the effect becomes extreme. Time slows to a crawl. From afar, something falling into that well looks frozen, not because it stopped, but because time itself has stretched so far you can barely see it move. The signals it sends are slowed, smeared, delayed. That's gravitational time dilation, not optional, not rare, built into the equations, as normal as mass or motion. So now we have two ways time can bend, through speed, through gravity. And those bends aren't distant, they're all around. Your body has mass, so does your chair, so does your phone. Every object leaves a tiny dent in the fabric, and every dent shapes the experience of time. The effects may be too small to notice, but they are real. Stack those curves together, the movement of stars, the weight of planets, the spin of galaxies, and you get a picture that is not flat, not even. It's dynamic, it's textured. Time doesn't flow the same in every place. Sometimes it rushes, sometimes it rests. That's not an error, it's the design. You can picture it like this: a map. On a flat map, the shortest path is a straight line, but on a globe, that path is a curve. Time works the same way. The path between two moments isn't always what you expect. It depends on the terrain, and that terrain changes as mass moves, as energy shifts, the fabric flexes. That becomes especially important when we look back, when we peer into the early universe. Just after the Big Bang, everything was hot, dense, compressed. Space-time was curved beyond what we can fully imagine, and in that curve, time behaved differently. Not just faster, not just slower, but under different rules. Rules we're still uncovering. As the universe expanded, space-time relaxed, and with that change, time changed too. That's why understanding the early universe is so hard. We're not just rewinding the clock, we're chasing a clock that's changing shape as we go, not just counting backward, but bending backward through a shifting field. The same applies when we look ahead. As the universe expands more, as its structure thins, time may again shift. Not metaphorically, but physically. Not because something tells it to, but because space-time allows it. So when we say time is curved, we don't mean it poetically. We mean it literally. Time behaves differently depending on where and how you ask it to move. Simultaneity breaks down. The answer to, what time is it, depends entirely on location. That's not discomforting. That's beauty. A fabric so subtle it accounts for everything. But that raises a sharper question. What happens when those curves grow so steep that space-time folds in on itself? What happens when the structure stops holding? Black holes, singularities, the earliest blink of the universe. These are not just locations. They are limits, points where the equations break, where space-time tears or becomes too sharp to follow, where time itself may end or may mean something entirely new. We'll move toward those frontiers, but before we go there, remember, the curves are not just far away. They're here. Every clock you've seen, on your wall, your wrist, your screen, is walking its own line through a curved sheet. Your thoughts, your choices, your life, they don't just happen in time. They help shape it. That isn't poetry. It's physics. Relativity makes it clear. Time is never flat. Curves are built into every second you feel. So when we ask again and again whether the universe knows what time it is, we have to be more precise. Where? For whom? In what conditions? Because there is no single answer. There are only many paths, many threads, many clocks, each one shaped by the fabric it walks on. We'll follow that fabric further next, into sharper bends, deeper wells, stranger edges. You can trace time backward in many ways. Memory, books, ice cores, planetary motion, the decay of elements, each layer thinner than the last, each signal fainter. But the line holds. Physics lets us rewind, and if you go far enough, you don't just approach ancient things, you approach the boundary of time itself, not because the evidence fades, but because the concept itself begins to fray. Did time have a beginning? That question feels strange. We're used to before and after. We expect every moment to come from something. If a glass falls, there was a second before it hit. But what about time itself? Can it have a before? That's where our minds stutter. Because when you ask what happened before time, you're using time words to describe a place where time may not exist. It's like asking what's north of the North Pole. The sentence makes sense. The question doesn't. According to our best models, the universe is around 13.8 billion years old. That's not a guess. That's measured. Expansion, light, element ratios. They all trace back to a single, hot, dense moment, the Big Bang. But the Big Bang wasn't an explosion in space. It was the expansion of space. There was no outside, no center, just a field stretching. Every point came from a smaller version of itself. The math takes us back to a singularity, infinite density, infinite temperature. But that singularity isn't a real location. It's a breakdown, a signal that our math stops working. Beyond it, we need quantum gravity, a theory we don't yet fully hold. Still, relativity gives us a starting line, not a wall, but a line, a first mark, a point where time as we know it began, not something before time, just the start of time. And that's hard to hold. We want to ask what came before, but there was no before. There was no time to be before. That's not wordplay. That's the shape of the theory. Some processes stretch like quiet shadows across the fabric of the cosmos, while others speed forward as if time were skipping stones over still water. In this strange terrain of relativity, clocks do not all tick the same. One might count seconds swiftly, while another drags each one as though reluctant to let go. The flow of time bends in ways our ancestors could never have imagined. No longer a river with a single steady current, it resembles instead a winding field with hidden slopes and shifting paths. Whirlpools, eddies, ripples of gravity and speed create local variations, slowing time here, speeding it there. Physicists no longer picture time as something that simply flows. Instead, they see it as a coordinate, one axis in the four-dimensional geometry we call space-time. Space offers three directions. Time offers one more. Together, they do not just say where you are, but also when. You do not merely move through space. You move through a woven field of possibility, where the geometry of time changes depending on how fast you travel or how deep you are in a gravitational well. The faster you move, the more slowly your clock ticks. The deeper you fall into gravity's pull, the more time stretches. Two observers can meet at the same destination, having lived through different amounts of time. What we once called a river now feels more like a vast, invisible terrain, where the shape of your journey is shaped not by direction, but by curvature. This doesn't mean time is an illusion. It means that what we call now, what we experience as the present, is the result of a very specific kind of movement through this flexible web. Our biology, our memories, the thermodynamic arrow of entropy, all of it aligns to favor one way through this landscape. We feel time passing forward, but the structure beneath that feeling may not agree. Some physicists imagine a timeless map, where past, present, and future all coexist like locations in space, fixed, enduring, waiting to be passed through. The moment of your birth and the moment of your death may both exist, laid out within the same geometry, even if you can only walk one line through it. That's the mystery. Physics allows the map, but your consciousness allows only the journey. You remember behind you. You anticipate ahead. But you live only now. You move through a web that doesn't insist on a direction, yet you follow one anyway. Why? That question remains unsettled. Some scientists argue only the present is real. The past has vanished, and the future has not arrived. Others suggest every moment is equally valid, equally present, and the feeling of movement, of change, of time flowing is just the echo of memory and perception. We cannot step outside time to examine it. We are within the fabric trying to understand its weave. Still, we know that time is not a straight, universal road. It curves, it flexes, it behaves more like a web of relations than a line. And within such a network, order matters, but direction might not. You feel time move forward because of how your brain records experience, because of how entropy increases, because of how cause leads to effect. But underneath, within the equations, lie stranger paths, paths that stretch backward, paths that loop or diverge. These are not metaphors. They are possibilities built into the mathematics of the universe. They do not change the way you age or breathe or think, but they whisper of something deeper, something richer. So when you walk through your day, you are not drifting along a river. You are stepping through an intricate landscape shaped by mass, by speed, by curvature. Every step you take is subtly guided by this invisible architecture. If you ask why time moves forward, what you're really asking is, why does the local shape of space-time favor this particular direction? And the answer seems to be, it began that way. The universe started in a low entropy state, a rare, special arrangement, and from that structure emerged complexity, memory, experience, decay, growth. Time's direction may not be fundamental. It may be inherited from the very birth of everything. And in some distant region of the cosmos, the rules might run differently. Maybe entropy flows backward. Maybe time unwinds, not as a contradiction to physics, but as one of its allowed shapes. We don't know, but the math allows it. And so, we hold it gently, not as certainty, but as potential. If time were simple, we would not need to draw it in curves. We would speak of it like a ruler, a grid, a number line. But time resists that. It bends when we move, it bends when we fall. This is where Einstein enters. In the early 1900s, he took what seemed intuitive, space and time, and showed that they were two faces of the same structure. Space-time. That structure flexes. It responds to mass. It responds to motion. It does not stand still. It shifts. Time, in Einstein's view, was not a silent stage where events unfolded. It was a participant, a character in the story, shaped by the forces around it. Start with special relativity, the version of the theory that deals with motion. When you move near the speed of light, time slows for you. Your seconds stretch. Your processes decelerate. You age more slowly. Not because something is broken, but because you are tracing a different path through space-time. This is not just theory. We've seen it. Particles moving quickly through accelerators decay more slowly than those at rest. Their internal clocks run longer. Even astronauts in low Earth orbit circling at high speed age fractions of a second less than their Earthbound counterparts. It is small, but it is real. Speed bends time, then comes general relativity. Gravity too curves the fabric. Imagine space-time as a sheet stretched taut. Drop a mass onto it, a planet, a star, and the sheet dips. That curve changes how nearby things move. They fall, not because they are pulled, but because they are following the straightest path through bent space. Orbits are just objects, rolling through a curved geometry. And time feels the dent too. The deeper the well, the slower the clock. A mountaintop ticks faster than sea level. Your head ages slightly more quickly than your feet. These effects are tiny near Earth, but immense near something like a black hole. There, at the edge, the event horizon, time almost stops. From a distance, anything falling in appears to freeze, its light stretched, delayed, smeared across the ages. Not because it halted, but because time itself has stretched beyond recognition. Time does not resist this curvature. It obeys it. Wherever mass gathers, wherever motion accelerates, the geometry flexes, and time bends in response. Even you, sitting still, create a tiny depression in space-time. Your presence is part of the architecture. You shape time just by being. This is why relativity matters. It tells us that time is not a constant tick. It is a texture, a property of the universe shaped by everything in it. Stack the influences, speed, gravity, movement, mass, and you get an intricate dance of local times, each slightly different from the next. Sometimes the differences are imperceptible. Sometimes they are cosmic. It is like comparing a flat map to a globe. On the map, every centimetre looks equal. But on the globe, distances warp. Time works the same way in curved space-time. The shortest connection between two events may not be the most obvious. It may be an arc, a bend, a soft spiral through hidden geometry. That geometry is alive. It changes as energy flows, as matter shifts, as the universe breathes. Time flows differently now than it did long ago. In the early universe, everything was compressed, dense, hot. Space was tight. The curves were sharp. Time itself may have obeyed different rules, not just ticking faster or slower, but operating within a different framework entirely. As the cosmos expanded, that framework relaxed. Space-time stretched, clocks changed their rhythm. And now, in the vast cold spaces between galaxies, time flows in yet another way. Gentle, slow, extended. Not because of some external influence, but because the very fabric allows it. So when we say time is curved, we mean it precisely. Clocks disagree not because they are faulty, but because they inhabit different pockets of the geometry. Ask, what time is it? And the answer depends entirely on your position, your velocity, your gravity. There is no universal clock, only local ones, each shaped by the curves it rides. This leads us to a cliff's edge, a place where the curves grow wild. Black holes, singularities, the beginning of the universe. These are regions where the fabric folds so sharply that our equations collapse. The math stops working, the structure buckles. Time, as we understand it, may dissolve. We do not know, but we are getting close to these places. Theoretically, observationally, imaginatively. And yet, even here at home, the curves remain. Every thought, every memory, every second on your watch, all are affected by the gentle dents and bends of the world around you. You are not simply in time. You are part of it, interwoven, and relativity insists. This is not poetry. It is fact. There is no such thing as time without curves. So when we ask if the universe knows what time it is, we must ask more precisely, where in the universe? For whom? Moving how? Under what conditions? Because there is no single answer, only local truths, measured against the shape of the surrounding space-time. Soon we will explore sharper curves, the ones that test the limits of understanding. But before we cross those thresholds, we pause here. Because even though we can trace time backward through memories and fossils and starlight and atoms, each step takes us closer to something stranger, a question not just of events but of existence. Did time begin? And if so, what does that mean? It's not an easy idea. Everything we know seems to have a before. A tree falls because it once stood. A sun explodes because it once burned. But if time itself had a beginning, what came before? The answer may be, the question dissolves. Before is a word that assumes time. But if time began, then there was no before. Asking what came earlier is like asking what lies north of the North Pole. The concept reaches beyond its domain. Our current models suggest that the universe has an age, about 13.8 billion years. That number is not a guess. It comes from many directions: the light of distant galaxies, the cooling afterglow of the Big Bang, the ratios of hydrogen and helium. All of them point to a moment, a beginning. But that beginning wasn't an explosion in space. It was an expansion of space, not within something, but of everything. Every point in the universe was once compressed into a smaller state. From that state, space stretched, and time began. Run the equations backward, and they lead to a singularity, a point of infinite density and temperature. But physicists do not believe this is real. It's a sign that the math has reached its limit. General relativity, powerful as it is, breaks there. What lies beyond? We don't yet know. We need a new theory, one that marries the smooth curves of gravity with the jittering chaos of quantum mechanics. A quantum theory of gravity. Still, the framework we have draws a boundary. Not a place, but a moment. According to this view, time itself begins at the Big Bang. Not in the way a clock begins after a pause, but in the way a direction emerges from a point. There was no before in the way we understand it. No ticking, no intervals, no moments. Time, as a dimension, came into being. That's hard to imagine, because we are time-bound creatures, shaped by it, built on it. To picture a moment without time is to reach for something outside our own nature. But that is where the evidence leads, and so we follow. Radiation drifts through space like a soft echo across an endless sea. Particles gently interacting, decaying, shifting, responding, every subtle exchange, dividing moments into meaning. We call this passage of time, but in the distant future, when the universe reaches its quietest state, the changes grow still. We speak of heat, death, a time when entropy is full and useful. Energy has ebbed away, but this isn't just a universe gone cold. It's a universe stripped of contrast. No stars to light, no planets to turn, no matter falling into form or breaking apart. The familiar rhythms that once hummed beneath. Reality grows silent. Time itself remains, but without change. It has nothing left to measure, and that changes everything. We imagine time as a flowing stream separate from the rocks and trees it moves past. But in modern physics, time isn't a stage. It's woven into the dance of matter and energy. In Einstein's theory of relativity, time is not absolute. It bends and curves shaped by motion and gravity. Clocks tick differently, depending on where they are, how fast they move, or how much mass surrounds them. There is no universal, now only local rhythms, and in quantum mechanics the picture blurs even more. In some interpretations, time isn't fundamental. It doesn't even appear at the root of the equations. Systems evolve in relation to one another. An atom spins, a photon moves, and from their comparison we assign the notion of time. If nothing changes, if everything becomes still, then nothing remains to compare. No tick, no tock, no before or after. Imagine a room where nothing moves, no particles drift, no atoms tremble, no light glows, no warmth seeps through in that room. You could say time is passing, but what proves it, with no events to observe, with no difference to perceive? Time becomes a hollow idea, like a shadow without shape. In such a place, not only is motion gone, but even the potential for motion has dissolved, and with that time becomes unreachable, defined in theory, but absent in experience. And this matters, because the universe is heading there. Entropy will continue to increase, stars will burn out, black holes will evaporate, and what remains will be a thin spread of near motionless particles, a whisper of photons and maybe neutrinos stretched across an expanding space, with nothing left to interact, no new forms to grow, no sparks to ignite. Pattern is lost, and with it, the ability to mark time. The coordinates still exist. You could label a moment, but moments lose meaning when they have no connection to others. Some physicists say this is the end of time, not its vanishing, but its fading away. Time becomes like a ruler in a universe without edges, a tool still present, but with nothing left to measure. And this is where the idea of a ticker returns. A ticker is any cycle, any change, a swinging pendulum, a decaying atom, a folding star. Time is defined by those comparisons, change against change. When all the tickers vanish, time does not cease, it simply becomes undetectable. That is the truest form of the heat. Death, not destruction, not silence, but sameness. Nothing happens, and so nothing passes. And time, though, still part of the structure, no longer ticks. Does this make time an illusion? Not exactly. Time still exists in equations. The universe still has structure and history, but what we call experience, what we call now, depends on motion, and motion depends on difference. Without that, time becomes invisible, not wrong, but hollow, not gone, but empty. It isn't the same as death. It's not even an end. It's a flattening. The markers of time become so spread out, so even they no longer create change, no ripple, no rhythm. And again, the question returns, if there is no change, is time still real? Some physicists say yes, others say no, and some say it doesn't matter, because a universe without change has no observers to ask the question. No, processes to mark answers, no place. No when, just a smooth stillness. But we're not there yet. Our universe still breathes. The earth spins, the moon pulls oceans, the sun emits light. Neurons fire, air vibrates. Stars are born, galaxies collide. And every one of these is a ticker, everyone a beat in the symphony of time. We are still wrapped in motion, and so we still carry the rhythm. And from this rhythm rises the question, what happens when all the clocks stop, when the last atom decays, when the final collapse completes, when the energy sinks to its lowest possible level? What remains is a universe with a coordinate called time, but no rhythm to follow, no cycle to count, no process to note, just a flat line stretched across forever time. Without a ticker, does not die, but it retreats into abstraction, a thread with no tension. Until now, we've followed time through large things, stars, black holes, galaxies, the universe itself. But time is not confined to scale. It shows up even in the smallest corners, the quantum world where reality itself flickers. And there the concept of time grows stranger. Still, classical physics gave us certainty, location speed paths through space and moments mapped to clocks. But quantum mechanics unfolds as a sea of probabilities. Particles don't travel like marbles. They exist in clouds of potential, likely here, possibly there, and those probabilities shift, they evolve. But how do you speak of time in a world without a clear before and after in quantum theory? Time is not something you directly measure. It's a parameter built into the equation we use to describe change. Take the Schrödinger equation. It describes how a quantum system evolves over time, but it doesn't define what time is. It assumes time already exists, and shows how wave functions change within it. The structure depends on time, but cannot explain it. And when you try to build a clock from quantum pieces, the rules begin to blur. We do build atomic clocks comparing vibrations in atoms as they shift energy states. But deeper down, a single quantum system exists in superposition, not in one state, but in many. It doesn't tick, it hovers, and only when it is observed, when it interacts with its surroundings, does it select an outcome. Until that moment, time doesn't manifest. It floats as potential. This opens a fundamental problem if the smallest parts of reality do not follow clear timelines. What does that say about time itself? Some physicists believe time is not a foundational property, but an emergent one like temperature. It doesn't apply to one molecule but arises. When many interact, time, they say, is a statistical result. When enough quantum systems link and compare outcomes, the concept of time appears, Others push further, suggesting the universe is timeless at its base, and change is merely comparison between static relationships. This is the problem of time in quantum gravity, one of physics' deepest mysteries. When we try to unite quantum mechanics with general relativity, the equations don't easily agree time. As we know, it doesn't fit naturally. It must be added back in, patched through assumptions, or derived from coarse approximations. And this leads to another profound question. If time isn't truly there, why does it feel so constant? One idea is decoherence when quantum systems entangle with their environments. Possible outcomes collapse into actual events. Each interaction writes a sliver of history, stacking observations into sequence. So maybe time isn't a flow but an archive of changes, each one creating the impression of a timeline. Still, even if time is emergent, quantum systems change. Their wave functions evolve, and those shifts are the tiniest pulses of reality. But they aren't smooth, they jitter. They hop from one possibility to another, only when measured. The journey is not a curve, it's a leap, a flicker of probabilities made real through observation. And that flicker, that jitter, is not noise, it is the tick of the quantum world. Even empty space is not truly empty. Quantum field theory tells us the vacuum is full of fluctuations, particles rising and falling, fields pulsing. Even at absolute zero, the void moves. This is why particles can appear from nothing, why dark energy pushes space to expand, why stillness is an illusion at the smallest scales. In quantum decay, an atom does not wait for a moment to tick it. Simply changes unpredictably governed by probability. Its half-life defines a group, not an individual. Each instance is a flicker from the quantum depths in quantum tunneling particles, past barriers they shouldn't not. By breaking rules, but by dancing through probabilities, a particle can appear beyond a wall without ever climbing it, and even in photosynthesis or cellular processes, the same quantum rules guide life, coherence, tunneling, interference. They shape the world not as curiosities but as essentials, and beneath it all the jitter continues. It makes time at the smallest scales, messy, unpredictable, unassignable to a universal. Now you can't rewind a quantum event, you can't predict its exact future. This isn't a flaw, it's the feature of our universe. So what is time in this quantum fog? It's not a ticking clock, it's the collapse of possibility into presence. Not a smooth stream but a foam of maybes becoming moments. And in some interpretations, those other maybes never disappear, they branch into other realities, while in others they vanish forever. But in all of them, time appears only at the point of interaction, not before, not below, not flowing underneath, but rising in the act of measurement, and this reshapes our sense of sequence. Before and after are no longer absolute. They depend on what you measure, who observes, and what you count as change. Time at this level may be more like a sea, possibilities smooth in one place, choppy in another, still in some corners, bubbling in others. Those bubbles are the flickers, the changes, the seeds of all we know. When enough flickers align, patterns grow, clocks form, rhythms emerge, and what we call time becomes familiar. But under it, all time remains jittery, not smooth, not stable, not fixed, just a comparison, a memory, a sequence of changed states. And even with all the randomness, those flickers don't cancel out, they build, they compound, they create. And perhaps that's where time truly begins, not in celestial clocks, not in spinning planets, but in the moment when a quantum state becomes something real, when possibility folds into memory. Not with a tick, but with a flicker. And as you sleep, you carry that flicker within you. Time doesn't require you to be awake. It moves even in your dreams. Not as a machine on your wall or a shadow from the sun, but as something inside a quiet rhythm that holds you through the night. We dream in time. We move through imagined spaces with beginnings, middles and ends. Events unfold in silence, and still they form a story with sequence. And if none of it truly happened, if your body never left the bed, where did that time come from? Perhaps from the same place as all time. From change, from flicker, from the dance between stillness and becoming. And as you drift deeper, that rhythm stays with you, soft, quiet, constant, the smallest tick in the dark. The human brain does not hold a central ticking metronome, no clock etched into its folds. Instead, time is built from waves, from chemical messengers, from rhythms that pass between neurons and through entire regions, loops of electrical flow that rise and fall, marking change rather than counting seconds, even in sleep. Some of these loops keep circling, and deep inside sits a small cluster of about 20,000 neurons, the suprachiasmatic nucleus. It does not know time in the way a clock does, but it senses light through the eyes, and from that light it guides the circadian rhythm, your body's inner day. This rhythm flows not with precision but with steadiness, controlling sleep, hormone pulses, body warmth, not exact seconds but reliable patterns. This is one kind of time within, but not the only kind. The cerebellum helps track fractions of a second. The basal ganglia feel seconds and minutes, especially through motion and reward, and the prefrontal cortex stretches across longer spans, attention and expectation. Each part of the brain beats with its own timing. They do not all agree. There is no single now, only a fluid shared map that shifts in context. When bored, time drags. When focused, it vanishes in fear. Time stretches. In repetition, it fades. Your perception of time is a conversation among regions, and that conversation is always active even when you dream. In dreams, the outer world goes silent. Your muscles go still, but your brain lights up in ways stranger than wakefulness, especially in REM sleep where most vivid dreams occur. Vision centers awaken emotion. Flares, motion circuits stir. But the part of your brain that checks for reason and truth, the dorsolateral prefrontal cortex, grows quiet. And so dreams unfold, strange and vivid and unquestioned. They carry sequence, they carry memory, they flow even when logic sleeps. And within that flow, time continues. It may not map cleanly to clocks, but it feels real enough to place events before and after long dreams can pass. In minutes, short ones can stretch through imagined years. And in studies, lucid dreamers trained to move their eyes within the dream have shown that timing inside a dream can match waking intervals, though not always. Dream time loops, it skips, it races, but still it feels like time, because the brain does not measure seconds. It gathers change. It builds a narrative from differences, and memory is the spine of that narrative. When much happens, time feels full. When little changes, time thins. This holds awake and dreaming both. And in dreams without clocks, without schedules, the shifting images still build. Time's shape difference, motion, imagination. These are enough, and they show us something key. Time is not only external, it is internal, a rhythm of thought, a measure of memory. And this rhythm differs for each person. Two people in the same hour live it differently. One feeling chase the other at peace, and it changes with age. Children feel time stretch because each day brings something new. The brain records novelty, and novelty expands experience. Each small event builds a pattern, and so a single afternoon feels endless. To a child, adults live more repetition, and the brain condenses the familiar days, begin to blur, and time appears to race. Not because it does, but because fewer memories are laid down. Dreams offer a counterpoint, they invent. They surprise, they stir memories into strange new forms, and that novelty lengthens the moment again. In dreams, time feels real because it holds difference. The brain responds not to the passage of seconds, but to the richness of change. And that elasticity is not a flaw. It is a tool. The brain is built for useful time, not perfect time. It needs coordination, attention, the ability to respond. And so even in rest, even in sleep, it continues dreaming, sorting, replaying, keeping rhythm. And that rhythm leads us toward the deeper mystery. If time feels real when made of dreams and memories, what is it really? Physics ties time to motion, to decay, to transformation of energy, but the mind builds time from perception, from emotion, from attention. The two are not equal, but they echo one another. A decaying particle ticks forward. A firing neuron does too, one by nature, one by need, and you live inside both at once. You orbit the sun, with Earth bound to gravity, bound to the passage of days and years, but within your skull, another time flows. the time of waiting, the time of reaction, the time of memory. And when you sleep, that time shifts, but it does not vanish. It reorganizes it. Dreams even in altered states. The brain holds sequence. It builds moments. It insists on time because time for the mind is order. It is the thread that ties thoughts together. It makes cause and effect possible. It shapes narrative. It grants meaning. That is why, even in silence, even in darkness, time appears. It is one of the oldest structures of awareness. Look up at the moon and it looks back without gaze. It sees nothing. It thinks nothing. It knows nothing. And yet it sits there, casting light across night. And in your chest, you feel something calm, maybe distance, maybe rhythm, and you might whisper to yourself, "It's night. Now the moon is out." But the moon does not know this. It has no brain, no awareness. And that question does. The moon know? It's night. Is not about the moon, it is about time. We carve the world into parts, day and night, morning and evening, this week. Last month we map our living onto the motions of sun and moon. We build clocks from their rise and fall, but nature itself does not slice time that way. The moon reflects light, half lit, always, half dark, always. What side we see depends on where we are not, on what we believe. It is not telling us anything. It is not trying to be a calendar, and yet we made it one. Its phases mark the month. Its orbit stirs the tides. Even today one could guess the hour from its arc in the sky, and this tells us something. Time continues with or without us. The moon does not notice your gaze. It circles in gravity, unmoved by your meaning, and yet your awareness gives it shape, gives it purpose, gives it place. You say, "This is night," because the moon shines above. But that night lives in your body, not in the rock above. So what happens to time when there is no one to see it? Does it still pass? Does it still matter? This is not just a poetic puzzle. It is a question physics asks. Does time exist without observers? Or is it a thing made through measurement, through memory, through mark on the world? Many physicists treat time as structure and axis along which events unfold. No witness required. Cause follows effect. Sequence forms order. But in quantum mechanics, some interpretations suggest that without observation, reality remains in haze. Events wait for interaction to fix them in place. This does not mean the mind controls the world, but it does hint that attention changes outcomes. Still, the moon orbits the Earth. Gravity binds it, and it does not wait for eyes to do so. Yet, if no one sees the moon, is there still night, or only position, only geometry, only a place in cycle, our feelings, our frames, our calendars? Those are human layers we place atop a moving sky. They are not lies, they are not mistakes, they are tools, ways of shaping experience, ways of living in rhythm. We need to name change, we need to expect return, we need to sense motion, and the moon, even silent, becomes our marker. It is unaware, yet it builds our sense of time, not by acting, but by moving, by repeating, by staying in pattern. So we say it is night. We feel its difference. We dream beneath its glow. But the moon is unchanged by our knowing. No memory, no intention, no idea of now. And still, it is part of how we structure time. Its motion shapes our days, our stories, our sleep. Even when it does not care to, we ride its orbit. We count its phases. We measure with its silence. And that shows us the deeper truth. Time is not always something you feel. Sometimes it simply is, and the feeling may come or not, but the structure continues. You may forget to watch the moon. It will still wax and wane, and in that sense time has two lives. It is the scaffold, the frame, the constant of physics, the march of entropy, the pull of gravity, the steps of decay, and it is also the stream of experience, the changing moment, the personal passage of hours. It is both independent and intimate. The former exists without us, the latter only within us. And we forget this easily. We point at the clock and call it time. But the clock is our craft. Its tick is a choice. Its minute an invention. we live by slices, not always by seconds. The brain does not agree with the machine. It stretches and shrinks, it rushes and stalls. The moon does not know it is night, but we do, and in our knowing, night becomes real, not from declaration, but from sensation. We feel it in our bones, in our breath, in our stories. We rest because it is dark, and we say, it is time, and so it is. And from this layering, time becomes more than motion. It becomes shared, meaning the bases, the universe is ticking. The top is memory, and between them is rhythm, the moon. Its indifference gives us order to borrow, to map, to turn into calendars and rituals and tales. And from that mapping we synchronize, not because the moon told us, but because we needed something steady, something vast, something silent enough to hold our meaning. This is the paradox. Time does not stop if we turn away, but the time that matters, the time that moves, hearts only lives when we notice. And so the moon, though blind, plays its part, shaping our night-giving form to the moment, even without thought. And that is enough, because we are here, we are awake, we are aware, and from our awareness time takes shape. Events align, transitions unfold, beginnings rise, endings fall. Not because the cosmos commands them, but because we remember, we sense, we mark. We always live in the now. The past is memory, the future imagination. Only now is felt, but what is now? It feels sharp, like a line between what was and what may be. It feels like the place of choice of presence, but try to hold it. And it slips. Try to name it, and it ends the instant you call it. Now it becomes then the present cannot be pinned. And in physics, it does not need to be. The equations do not single out a moment. The universe does not highlight a today. The laws unfold across frames indifferent to when only caring for how time is a coordinate, not a heartbeat. And yet we live in its pulse. There is no privileged now in the universe, no single moment shared by all observers. In Einstein's theory of relativity, what seems to be now for one person might not be for another. Two events that appear simultaneous to one frame of reference may occur at different times in another, depending on how fast each observer is moving. This isn't just a matter of clocks ticking differently. It's a deep truth about how space and time are woven together. There is no universal present, and yet inside your mind, you feel there is. You wake, you move, you choose always inside what feels like now. But the present moment is not a fixed point. It's a construction in your brain, a fragile assembly of perception and memory and expectation. Every thought, sensation and action you experience is delayed by a few hundred milliseconds as your brain gathers information, aligns, it smooths it, and presents a version of now that is already behind your real-time self, always slightly catching up. Not fake, but filtered. Not exact, but useful, because what the mind offers you is coherence, a stream that feels smooth enough to live in even when it's gently distorted. That coherence is easy to stretch. You've felt it. Time slows when you wait. It races when you're distracted. Even your sense of whether two things happened at the same moment can be shifted by the brain. Experiments have shown that when sound and sight arrive with a slight mismatch, your brain often adjusts them to feel aligned. It creates an internal, now not by measuring perfect simultaneity, but by stitching fragments into flow. Your present is not a point, but an interval, a soft-edged window, long enough to hold a breath, short enough to miss a blink. Psychologists call this the specious present. It's usually less than a second, but it's enough for meaning to form. The shape of now depends on context. If you're in danger, the window narrows. Time feels sharp if you're calm. The window expands. Time flows slow and gentle. These changes are not conscious choices. They're part of your biology. Your brain shifts the sense of now to meet what you need to survive. This is why moments feel different. Not because time outside is changing, but because the frame your brain draws around the moment keeps shifting, and sometimes it even reorders events to make sense of them. Backdating one input to match another, so you feel them as one. You feel the world in real time, but what you feel is assembled. Your brain synchronizes touch with heat, even though they travel along different nerves at different speeds. The experience is stitched together into one now, a reconstruction, not a lie, but an accommodation. And that's enough, because you don't live in physics, you live in perception, and that perception demands continuity, a steady now that lets you act and remember and plan. And it's that steady feeling that gives life its rhythm, not a tick, but a drift, not a dot, but a stream. And yet while your now moves gently forward, the universe does not share it. There is no cosmic now, no instant that everyone agrees on. Even near Earth this becomes clear. Satellites in orbit experience different gravity and motion than we do, and so their clocks tick at different rates. GPS engineers have to correct for these relativistic effects, or else our navigation systems would drift kilometers each day. This isn't theory, this is practice. Time bends even in low orbit. Now take that to extremes. Fly near a black hole, and time stretches dramatically from a distant view. Your seconds might become hours, your minutes days. Not because your clock breaks, but because space and time are warped. You'll now become someone else's distant past or distant future. Clocks near gravity tick, slow clocks in deep space tick fast. There is no master clock in the cosmos, only clocks that depend on paths and positions and speeds. And so two people taking different routes through space may return with different ages. Their journeys shape the flow of their time. This is not a thought experiment. It has been tested with particles and with precise atomic clocks. The universe allows it because time is not rigid. It flexes with motion and mass, and that flexing erodes the idea of a shared present. Even light doesn't fix this. It travels fast but not instantaneously. So every distant object you see as it was not as it is. When you look at a galaxy, 1 billion light years away, the light reaching you, now left long ago. And if they look back, they see your past too. You see each other as memories preserved in light. Even the cosmic microwave background, the faint echo of the early universe, is not the universe. Now, it's the universe then. 13.8 billion years ago, when atoms first formed, the sky is not the present. It is a map of history stretched across space. So the idea of now falls apart on cosmic scales. Instead of one time, there are many local times shaped by context, by gravity, by motion. Cosmologists define cosmic time, a kind of average based on the universe's expansion relative to the background radiation. But no observer lives in that frame. It's an idea, not a place. And so, in truth, everyone, every planet, every particle follows its own clock, not by choice but by nature. This makes time deeply personal, not just psychologically but physically. Your own trajectory through space-time defines how you age, how you change, how you perceive, and each trajectory is unique. So the question, what time is it, over there has no absolute answer. Only local clocks, only individual timelines, only events measured from somewhere. And when you look to the stars asking what's happening now, you're really asking what happened, then what light has reached you and what hasn't. There's no fixed now to stand in, only layers of delay, only pockets of order, only signals on their way through the dark. We try to tame this with calendars, with hours, with schedules. We say it's 10 o'clock, it's Tuesday, it's summer. But those are tools, not truths. Those are shared maps, built to keep our lives in sync, to help us agree on when to meet, when to rest, when to remember. But the universe doesn't keep that kind of schedule. It moves by laws, not by clocks. Those laws are reliable but not aware. They do not anticipate, they do not plan. If a star forms, it is not because it is time. It is because matter and gravity made it. So if a particle decays, it is not waiting. It is simply unstable. Events happen not by appointment, but by condition, and yet patterns emerge, orbits repeat, atoms resonate, stars pulse. And these rhythms give us the illusion of a cosmic metronome, but there is no conductor, just the physics of cause and effect. Atomic clocks remain precise for millions of years, not because they know the time, but because their structure vibrates consistently, and we borrow that consistency to build our calendars to mark eclipses, to remember solstices. And yet all of this rests on patterns, not plans. Nature offers rhythm but not intention. We impose the schedule, we build meaning into motion, we find our place by projecting structure onto flow. The universe does not keep time in our way, it simply unfolds, and in that unfolding, we find cycles, and in those cycles, we anchor our sense of now, a now, that is not universal, but enough for us to dream, to act, to belong. Some things happen in the blink of an eye, while others unfold slowly over eons. Stars are born not on cue, but when their ingredients cross a threshold, hydrogen fuses into helium. Not because it's scheduled, but because the temperature, pressure, and proximity align. The same holds true for comets returning, black holes forming, or planets orbiting. None of these events follow a master calendar. They happen when conditions demand it, not when a clock chimes. The universe is governed by thresholds, not appointments, and yet patterns emerge. And some of those patterns are so regular, we learn to count on them. Seasons, tides, eclipses. These recur not because they're marked on some cosmic planner, but because gravity, inertia, and geometry repeat their dance in familiar rhythms. We notice this repetition, and we build upon it, creating our own tools to keep time, clocks, calendars, time zones. They do not exist outside of us. They're conventions shaped by the reliability of celestial patterns. No galaxy recognizes a Tuesday. No neutron star cares for the start of a decade. The universe moves on unaware of the labels we assign to its cycles. But without those labels, planning falters, memory slips, coordination collapses. Without a structure to lean on, we find ourselves lost in a blur of change. So we carve time into shapes we can hold, hours, days, years, and then we assign meaning to them. We give ourselves birthdays, seasons, work hours, and rituals, each one grounded in a rhythm we've agreed upon, but the universe remains unmoved. It does not tick, it flows, and events emerge, not in response to time, but in response to physics. A comet returns, not because a calendar says so, but because its orbit closes the loop. A black hole appears not when the clock demands, but when a star collapses past a limit. The laws are always obeyed, but they never plan ahead. The universe is reactive, not prophetic. It responds, it unfolds, it continues without forecast. And yet from this unplanned unfolding, we extract structure, because structure is what we need to live together and to remember. Even the processes we count on, like radioactive decay, are governed by probabilities, not promises. We can say how many atoms will decay, but never which ones we know the shape of the forest, not the path of a single leaf. That randomness isn't chaos, it's a quiet uncertainty built into the rules of matter. Still, the averages are reliable. They let us design clocks, predict decay, and understand half-lives. And in pulsars, we find rhythms so stable they rival our best machines. Rotating neutron stars flash like distant lighthouses, and for a time we can count on their signal. But even they drift over long timescales. Their spin slows, their pulse changes. Nothing holds forever, not perfectly. The stars above seem steady, but they too change. Their brightness shifts, their orbits wobble, their chemistry evolves. And though they may shine for millions of years, no two are the same. Their lives shaped by gravity collisions and coincidence. Across cosmic distances we see echoes of ancient light, the cosmic microwave background. A whisper from the first moments of the universe tells us it was once hot and dense and has since stretched and cooled. The expansion follows patterns, curves, models. We trace it backward. We imagine it forward, but it's not timed by a cosmic metronome. It's shaped by dark energy, by mass, by rules we do not yet fully grasp. And still, we wonder how long will it continue, perhaps endlessly, perhaps not. The universe follows no master plan, just the physics of what comes next. So does the universe keep time, not like we do. Its rhythms are real, but they arise from relationship, not regulation. There is no celestial bell, no ticking at the core of reality, just interactions unfolding where and when they must. Gravity bends the clock, motion stretches time, mass tilts the scales, and still, we measure, And still we name the sun rises and we rise with it. The moon swells and we count the nights. We draw cycles around these changes, not because they need it, but because we do. In some distant future, long after the last star has faded and the final black hole has disappeared, the universe may enter a state with no events, no change, no memory, to mark one moment from the next, no observer to say what time it is, and perhaps in that stillness time, as we know, it will dissolve, not in a bang, but in a blur, not because it stopped, but because nothing remains to distinguish one moment from another. Yet even now, we ask about time, we structure our days, we remember and anticipate, not because the universe does, but because we do. It is a human gesture in an indifferent cosmos. We hold on to rhythms, we invent structure, not to match the universe, but to manage ourselves. And as we do, we turn something abstract into something shared. Time becomes a story we tell together, and yet time itself may not be eternal. Physics tells us it may have had a beginning. The Big Bang was not just the start of matter, but the birth of space and time itself. Before that, the word before might not even make sense. Our equations break our models stall. What existed before? Time is a question that might have no answer, and just as time began, it might also end. Entropy suggests a long fade toward stillness, a heat death, where all differences vanish, all motion ceases, all systems reach equilibrium. It's not a stop, so much as a quieting a place where nothing happens, and thus nothing is measured. Time becomes irrelevant, because without change, there's no direction, there's no before or after, there's only sameness stretched over an empty canvas. Other possibilities exist, perhaps a big crunch, where expansion reverses and everything folds back in, perhaps a big rip, where space stretches so far it shreds itself. Each idea speaks to a different kind of ending, but all raise the same question: does time persist without change? Some theories in quantum gravity suggest time is not even fundamental. It could be emergent, a shadow cast by deeper laws, a convenient way to organize patterns, but not a fabric in itself. And if that's true, then time might end, not through collapse, but through irrelevance, like a tool set down. When the task is complete in black holes, we see hints of this time near the event horizon. Slows to an outside viewer, objects falling in seem to freeze, not because they do, but because time warps their motion. What looks like a pause is a stretch, a distortion that reveals how flexible time really is. And so perhaps time won't stop all at once, but will vanish, piece by piece, as change disappears, as structure fades, as difference dissolves. What remains might still hold coordinates, numbers, labels, but without movement, they lose their meaning. Time is not just the order of things, it is the difference between them. It is what lets us say, this happened, and then that. And when there is no, then time fades, not in destruction, but in stillness. Until then, we live within it. We remember through it. We act with it, not because it commands us, but because it allows us. And that permission, that gentle unfolding, is what gives our days shape. You've followed this thought through a long, quiet spiral. Maybe you began curious or restless or just looking for peace. And somehow you've stayed through clocks and stars, decay and distance, and now you're still here. Not because time changed, but because your awareness did. And that's what matters, not the label, but the experience. This moment is not shared by the universe. It's not even exactly shared by the people around you, but it is yours, and that makes it real. Physics may not require you to feel time, but you do. You are the system that remembers not all at once, but in order. And from that order, you build continuity. You connect the past. You imagine the future. You breathe in this now and let it carry you. Whatever time is, it includes you, not as an outsider, but as a part of its fabric. You are not watching time pass. You are inside it. You are its pattern, its witness, its unfolding. And that is enough to give it meaning. Not because time cares, but because you do. And as long as you do, time is not just a measure, it is a story, and you are in it.